We're going to work on finding the x values of all local maximum and minimums using the second derivative test, and then we're going to find the x values of the inflection points. So first of all, the function we are dealing with, I think I could type this, f of x is x raised to the fourth minus 4x. If we take the first derivative and set it equal to 0, we'll find the x values of the local minimums and maximums. So I'm going to go f prime of x, and this is going to equal 4x cubed minus 4. And then I'm going to set that equal to 0. I'm going to factor out a 4 and get x cubed minus 1 equals 0. And then I'm going to divide both sides by 4 and get x cubed minus 1 equals 0. And I'm going to find that x equals 1. Now, the second derivative test means I find the second derivative, which is 12. Wait a minute, I'm going something backwards. Oh, that's right, which is 12x squared minus 0. And I plug in the x I found by setting the first derivative equal to 0 to find out if it's a minimum or a maximum. So if I do f double prime of 1, I find that I get 12, which is a positive number, which means my graph is concave up, which means if it's concave up, it looks something like this, which means that it is a minimum. And that's how the second derivative test works. Okay, so, and there's only one of them. We only found one x that makes the first derivative 0. So there's only one minimum or maximum. We did the second derivative test by taking the second derivative, plugging in the x we found up here, and when we find that it's positive, it's concave up, which makes it a minimum. Okay, now inflection points. Remember to use a number line to check. So I call this a sine line. So if I was going to do a sine line for the first derivative, I would put 1 on it here, and into the first derivative, which is 4x cubed minus 4, I would plug in a number before 1, like I'll try 0, and I find that this is negative, which means the graph is decreasing. And then if I plug in a number after 1, like 10, I get that this is positive, which means that the graph will be increasing afterwards, and I can see that I have a minimum. Now, for points of inflection, for this, you take the second derivative and set it equal to 0. So for us, we're going to take 12x squared and set it equal to 0 and find that x equals 0. So if I was going to make a sine line or a number line for the second derivative, oh, this is terrible, I'm sorry. This would be my second derivative, which is 12x squared. I'm going to plot 0 here. Okay, this is x equals 1 on this one, because that's where I found that I would have a minimum or a maximum. This is going to be x equals 0, because this is where the second derivative is in 0, where the second derivative is 0, and I might find a point of inflection. So I'm going to test it. I'm going to plug in, say, -1. When I plug that into the second derivative, I get that this is positive over here. And let's plug in 1, and it's still positive. So that means that I do not have a point of inflection. There is no point of inflection, and it's because the concavity did not change. At x equals 0. It's concave up on the left side of x equals 0, and it's concave up on the right side of 0. Now, I graphed this because I want you to see why we're getting these answers. So it's over here on board 2. This is that function x to the 4th. This is f of x equals x to the 4th minus 4x. Notice that, let's make a vertical line here. Let's make it skinny, and let's make it dashed, and let's make it orange. If I make a vertical line right here at 1, notice that's where the minimum is. It moved a little, but notice we have a minimum at x equals 1. Here at x equals 0, it didn't change from being concave up to being concave down. If it had done that, we would have had, oh, I need a, sorry, that's not what I need. I need a pencil. So if we had been first concave up and then concave down, it would turn like this. So here's how we have positive concavity, and here's where we have negative concavity. Or if we had been concave down and then concave up, it would look like this. And so this would be our negative concavity because it's concave down. And this would be our inflection point. And this would be our positive concavity. But notice here at our inflection point, this is clearly concave up to the right. And it's hard to tell, but this is sort of coming down. I'm sorry, it's crooked. And it's pretty much concave up also. So it didn't change concavity. This is concave up, although it's very narrowly so. And this is concave up. And so that's how come we got the answers over here on board 1. Thank you.